The ozonolysis of alkenes involves the use of ozone to cleave both carbon-carbon bonds, both the sigma and the pi bond of an alkene. The reaction has two steps: treatment with ozone followed by a reductive workup, and the products are carbonyl-containing compounds, namely ketones or aldehydes. In the first step of ozonolysis, ozone adds across the alkene pi bond, and this is described using three mechanistic arrows. The alkene pi bond attacks a terminal oxygen of ozone, and this displaces the oxygen-oxygen pi bond onto the central oxygen of ozone, thereby neutralizing its charge. Finally, the anionic oxygen of ozone attacks the carbon of the alkene that would otherwise have lost a bond. The initial product is known as a malozonide. It, however, is fairly unstable and fragments readily. The fragmentation of the malozonide is also described using three mechanistic arrows. The malozonide contains not just one, but two weak oxygen-oxygen bonds, and that's part of the reason that it fragments so quickly. The carbon-carbon sigma bond of what was once the alkene breaks and forms a carbon-oxygen pi bond. This displaces the central oxygen of the malozonide. And finally, the last oxygen of the malozonide donates a lone pair of electrons to form a pi bond with the carbon that would otherwise have lost a bond. This yields two fragments: a carbonyl compound, either a ketone or an alkene,